Hello friends, in this video, we are going to learn how to delete a given node from a doubly linked list. So the node to be deleted can be the head node or the last node or any intermediate node in the doubly linked list. We will be discussing each case. First, let us see how to delete a head node. So we have a doubly linked list here with elements 10, 20 and 30. Now to delete 10, which is the head, what we have to do is we will create a temporary pointer pointing to head. Now make the second node the head. We will set new heads priv to null. So the link is deleted now and the node with 10 is not a part of the linked list now. Still we have to free that space. So delete that node pointed by temp. So the process is now completed. And now let us see the code to implement this. So we have a function delete node to perform this task. So into the function we pass the head of the linked list and the key to be deleted. So here we have the key 10. First we will check if the linked list is empty. If so, deletion is not possible since there are no nodes to be deleted. So we have if head equal to null. And it is not, so declare a pointer temp pointing to head. Now we have temp pointing to head. And now we have to find the node to be deleted. We only know the key to be deleted, which is 10, but it could be present in any node's data part. So we have to find that node. So we can use a while loop for that. We have to iterate over the linked list till we find the key or reach the end of the list. So after the loop is terminated, we will have our required node pointed by temp. So we have while temp not equal to null and temp data not equal to key. So in first iteration, temp is pointing to head and not equal to null, so that condition is okay, but temp data is equal to key. So that condition fails since we have our key in the current node. So the control comes out of this loop and now in temp, we have node to be deleted. Now we have if temp equal to null. It means node to be deleted is not in this list, but here it is not. Temp is equal to 1000 here and not equal to null. So now the node to be deleted is found, and now is the time to check if it is head or last node or any intermediate node. So first check if temp equal to head, and it is. So it is the head node which is to be deleted. So first make the second node the head. So we have head equal to head next. Now head is the second node of the list. Now we have to remove the link or connection. So make new heads priv pointing to null. So write head priv equal to null. Now we have to delete this node and free this space. So write free of temp. So that's it. The node is deleted from the doubly linked list. Now let us see the intermediate node case. So we have this linked list here. Suppose we need to delete the node with value 20 here. First iterate the list to find it, and it is found now and it is pointed by temp, and it is an intermediate node. So what we have to do is we have to first remove the links and detach it from the linked list. So make its previous node's next pointing to temp's next node and temp's next node's priv pointing to temp's previous node. Now this node to be deleted is detached and now we can delete this node. So that is how it is done. Now let us see the code to implement it. Here key equal to 20. First we have to follow the same steps, the same code. Check if the linked list is empty, but it is not. So make temp point to head. Now iterate over the list to find the node to be deleted. So first temp equal to 1000 and not null, and temp data equal to 10 and not 20. So go inside and move temp to the next node. So we have temp equal to temp next. Now we have temp equal to 2000 and not null, and temp data equal to 20, which is the key. So this condition fails and control comes out of while loop. Now check if it is equal to null, but it is not. So now we have temp pointing to the node to be deleted. Next check if it is head, but it is not. Now check if it is the last node, and for last node, its next will be equal to null. So write if temp next equal to null, but it also fails here. So we have the else part for the intermediate node case. Here, we first remove this node temp from the linked list. Temp is the node to be deleted. So make temp's previous node's next pointing to temp's next node. So write temp priv next equal to temp next. Now make temp's next node's priv pointing to temp's previous node. So write temp next priv equal to temp priv. Now the node is detached and now we can delete it by using the function free. So that is how we can delete an intermediate node from a doubly linked list. Now let us see the case where we have to delete the last node. So we have this linked list here, and suppose we need to delete the node with value 30. First, iterate the list to find that particular node. And it is found now and it is pointed by temp. And it is the last node of this linked list. So what we have to do is, we have to first remove the links and detach it. So make its previous node the last node, and last node's next should point to null. So make its previous node's next is equal to null. And now we can delete this node. So that is how it is done. Now let us see the code to implement it. Here, key equal to 30. First we have to follow the same steps. First check if linked list is empty but it is not. So make temp point to head. Now iterate over the list to find the node to be deleted. So in the first iteration, temp equal to 1000 and it is not equal to null, and temp data equal to 10 and not equal to 30. So go inside and move temp to next node. In the next iteration, we have temp equal to 2000 and not equal to null, and temp data equal to 20 and not equal to 30. So again the condition is okay, so go inside and move temp to next node. In the next iteration, we have temp equal to 3000 not equal to null, so that condition is okay. But when we check the next condition, we have temp data equal to 30, which is the key. So the condition fails and control comes out of the while loop. Now check if it is null, but it is not. So now we have temp pointing to the node to be deleted. Next check if it is the head of the list, but it is not. Now check if it is the last node, and we know that for last node its next will be equal to null. So write if temp next equal to null, and it is here, which means this is the last node. So first make its previous node the last node. For that the previous node's next should point to null. So write temp priv next equal to null, and now we can use the free function to delete this node from the heap. So that is how we can delete the last node from a doubly linked list. Now let us see another case. Let us try to delete key 60 from this doubly linked list. First, we have to iterate over the list to find the node with 60, and we won't find it. And temp will reach the last node and finally we'll have the value null. So let us see the code and how it works. First, check if the list is empty, but it is not. So set temp equal to head and iterate over the list. So first, temp equal to 1000 and not null, and temp data equal to 10 and not 60. So the condition is okay. So go inside and move temp to next node. In the next iteration, we have temp equal to 2000 and not null, and temp data equal to 20 and not 60. So again the condition is okay. So go inside and move temp to next node. In the next iteration, we have temp equal to 3000 and not null, and temp data equal to 30 and not 60. So again go inside and move temp to next node. And now we have temp equal to null. And now when we check the condition, it fails and control comes out of the while loop. Now check if temp equal to null, and it is. So the node to be deleted is not present, so print key not found. So that was the 3 cases of deleting a node from a doubly linked list. If the node to be deleted is the head, then make the second node the head of the list and remove the link and delete the old head. And now if the node to be deleted is the last node, then make the second last node the last node by making its next equal to null and then delete it. And if it is an intermediate node, then remove the links and detach that node from the list and then delete it. Now, let us discuss about the time complexity of this operation. Actually, the time complexity of deleting the node is order of 1. We can accomplish this task in a constant time, but it is the time taken to find the node first. So the best case time complexity will be when the node to be deleted is the head of the linked list. So it will be order of 1. And the worst case will be when the node to be deleted is the last node of the linked list. Then you need to traverse the whole linked list to find it and then delete it. So if you have n nodes, then the worst case time complexity will be order of n.